Hello everyone, Mr. John here for Areteem Institute with this week's Thursday Tidbit. Today we're going to be talking about remainders when dividing by 11. So we've done a video in the past, we'll link it in the description below for remainders when dividing by 9. Dividing by 11 is a little bit similar, but it has a key difference that we're going to talk about in this video. So let's get started with an example here of what we're going to call the alternating sum of the digits. So given a 6-digit number, for example, 1, 2, 3, 4, 5, 6, the alternating sum of the digits of this number is going to be, well, we're going to alternate adding and subtracting, but the only trick is we want to do this right to left. And it is important that we kind of do this right to left. We're not going to worry about the details too much in this case. But the alternating sum of these digits is 6 minus 5 plus 4 minus 3 plus 2 minus 1, which is going to be 3. So if you had an odd number of digits, you would have ending with a plus. Here we have an even number, so it's plus minus plus minus. Right? Sometimes I like to put here at the beginning a kind of plus 6 to remind us that we're starting with addition. This is where the alternating sum comes in. So alternating sum means we're kind of doing this plus minus along the way. So the alternating sum of these digits is 3. Right? Just to summarize in general here what the process is, right? The alternating sum of the digits adds and subtracts the digits from right to left, as we kind of saw above. Now, why would we care about this? Well, that's what we're going to see on the next slide here. So the main idea then is for any positive integer n, the remainder when n is divided by 11 is equal to the remainder of the alternating sum of the digits when they are divided by 11. So this kind of gives us our rule here when we're looking for remainders when we divide by 11. You can replace the number with the alternating sum of the digits, and that will not change what the remainder is when you divide by 11. So this means if the number is divisible by 11, the alternating sum of the digits is also divisible by 11, but it also actually tells you that remainder as well. Of course, we could do this with the example we just did, right? So we said, what is the remainder now when 1, 2, 3, 4, 5, 6 is divided by 11? Well, we already saw that the alternating sum, right, let me just write this as alt sum, was equal to 3. So that's our answer. It's as simple as that, actually, in this case. We can do that alternating sum, 6 minus 5 plus 4 minus 3 plus 2 minus 1. That number here gives us the remainder when 1, 2, 3, 4, 5, 6 is divided by 11. So this tells us that the number itself is not divisible by 11, but it tells us 1, 2, 3, 4, 5, 3 is divisible by 11, right? It tells us a lot of information there in this case. Let's also, though, take a look at an example that shows things can be a little bit complicated here. So what if we kind of totally reverse the digits? We have 6, 5, 4, 3, 2, 1 instead. Well, this alternating sum is going to look very similar, right? So you might be able to see immediately what the alternating sum is, but just to practice going right to left, 1 minus 2 plus 3 minus 4 plus 5 minus 6. And this gives us the number -3. So this is a little bit worrisome because we don't typically like thinking about remainders being negative. So one of the things you can do, though, is if you have a negative remainder, you can actually add 11 to it to get 8. right? So this is when we have like a negative number. Notice that 3 plus 8 is 11. So it doesn't change the remainder when you add 11 to the number. And so we would say the remainder there is 8. If you wanted to kind of write this out with quotients and remainders, what you could say here is negative 3 is negative 1 times 11 plus 8, right? And this is your kind of quotient and remainder. So here you would have your quotient, and here you would have your remainder. And so that's where we get this remainder then of 8 in this case. So you take the alternating sum, just like the rule for 9, you maybe can repeat the rule, but here we have a small number anyway. But we just need to convert that negative remainder into a positive remainder. So if you have that negative number, you can add 11 to it, and we see that the remainder is 8 in this case. That's it for today's video. There's a lot of cool stuff you can do with remainders by 11. So take a look at our ZIML site for more practice problems with divisibility, with remainders and stuff. And check back each week for a new math tidbit every Thursday on our video channels. Goodbye.